So, Chapter 8 is the chapter that introduces you to trig, or trigonometry. If you look at the word trigonometry, you could break it down to figure out what exactly it refers to. The root word tri stands for the number 3. You know the root word gon, like in polygon? Gon means sides. And metri and metric is a root word that stands for measurement. So, literally, it's the measurement of things with 3 sides, triangles. Trigonometry is a measurement of everything having to do with triangles, hence why we started with Pythagorean's theorem and special right triangles. Now, while the category of trig actually refers to most everything that has to do with measuring triangles, when people say trig, they tend to think of what you're learning today primarily. There's 3 trig ratios that are the foundation of more advanced trig. So you learn these this year, you keep using these 3 trig ratios the rest of the semester, and also in your future years of math. The 3 trig ratios are called sine, cosine, and tangent. Copy these down on your notes under the trig ratios heading. Now, if you look at your calculator, if you have a scientific calculator, you will notice that there are buttons on it labeled sin, cos, tan. Those are the official abbreviations for sine, cosine, and tangent. Now, sine, cosine, and tangent are called ratios because ratio means fractions. And these 3 things stand for fraction equations about triangle sides. For example, sine stands for the equation you get by taking the length of the side opposite your starting angle and putting it over the length of the hypotenuse. This will make a lot more sense when you see an example. For now, just write down the equation. So sine equals opposite over hypotenuse, and which side you consider the opposite depends on what angle you're supposed to start at. See how the C, I'm so funny. This corner C is labeled with a theta symbol. That theta symbol, it's really like an X except for angles. So that's your starting angle that they labeled. So the side opposite of it, directly across from it, that's your official opposite side that you put in your equation for sine. Your equation or ratio for cosine is the length of the adjacent side over the hypotenuse. Adjacent, remember, just means next to, so it's the side that's next to your starting angle. That's not the hypotenuse, the adjacent leg side. And then your last equation is the tangent equation, and that is the length of the opposite side over the adjacent side. Now, these 3 equations you're going to use so often that you will need to memorize them fairly quickly. But here's the good news. There's a shortcut for memorizing them. Copy down this part in blue. SOHCAHTOA. SOHCAHTOA is really just a handy abbreviation to help you memorize your 3 equations. The SO reminds you that sine, where the S comes from, equals opposite over hypotenuse, over H. That cosine, C, equals adjacent over hypotenuse, A over H. And that tangent equals opposite over adjacent. So remember SOHCAHTOA, and you essentially will have your equations memorized. So in a question like number 1 on your notes, find sine, cosine, and tangent for angle N, you first want to label your starting angle on your diagram. Notice how they said sine, cosine, and tangent for angle N. Circle the N. That's telling you your starting corner. Mark it on your diagram. Now, based off of where N is, we could figure out how to label our sides, whether each side is opposite, adjacent, or hypotenuse. I usually label the hypotenuse side first. I'll write an H on the hypotenuse side because that's the easiest side to spot. It's the longest side, and the right angle is always pointing to the hypotenuse. Next, I always like to label the opposite side. The opposite side is across from or opposite from your starting angle. So label the 8 side opposite, or just O. And then the adjacent side is next to your starting angle, but it's a leg side, not the hypotenuse. Now that you have all your labels, you can use those labels to figure out your sine, cosine, and tangent equations. So the official way of writing an equation for sine is to actually use a sine abbreviation, even though it only cuts off one letter. Sin parentheses, and in parentheses, put the name of your starting angle. In this case, our starting angle is n, sin parentheses n. You'd read the sin of n, or sin of angle n. So sine of angle n equals opposite over hypotenuse. We remember that equation for sine is it's always opposite over hypotenuse for sine. The opposite side is 8. The hypotenuse side is 17. Let's just write all our equations first. And then we were talking about how sine opposite over hypotenuse would be 8 over 17. Cosine, what would cosine be? If cosine has to be adjacent over hypotenuse, it would be 15 over 17. What about tangent? Opposite over adjacent, so 8 over 15. We're done. We have our three ratios, or three trig ratios, sine, cosine, and tangent, figured out for angle n in this triangle. Question 2. Find sine, cosine, and tangent for angle A. When you try question 2 on your own in a moment, make sure you very carefully label that A is your starting angle. Which side would you label H for hypotenuse? Which side would you label O for opposite your starting angle? Make sure you caught that. It has to be opposite your starting angle. And then 5 would be the adjacent side, A. What would sine be? Sine is opposite over hypotenuse. That's a SO in SOHCAHTOA. 12 over 13. What about cosine? 5 over 13 when you do A over H for cosine. What about tangent? 12 over 5. And just leave it as an improper fraction. 12 over 5. Opposite side over adjacent side. Well done, guys. Now, these three equations, these three ratios, have a lot of uses. One of them is to solve for the missing side of triangles that would otherwise be impossible to solve. So on page 2 of your notes, copy down these steps for what to do to solve for missing sides in a triangle where Pythagorean theorem won't work. Notice, for example, here, we can't really use Pythagorean theorem because we only know one side. It'd be 6 squared plus x squared equals y squared. We couldn't solve that, so we need a different method, which is what you are learning today. So for step 1, copy this down. Step 1 is to label each side based on its location compared to angle. In other words, label the H, O, and A sides just like you did on page 1. That's how you start the problem. Step 2 is to choose the trig ratio that involves a combination of the known side and one variable side. So in other words, step 2 is to figure out whether you've got a sine, cosine, or tangent problem, which one of the three to use. Step 3 is to calculate the trig ratio for the angle using your scientific calculator. I'll show you how to do that in our first example. And step 4 is to cross multiply to solve for the variable. Now, let's see these steps in action. The steps are still there, just smaller. So step 1 is to label each side based on the location compared to your starting angle. Now, your starting angle in these problems will always be the one angle you know besides the right angle. So the one angle with a number in it, mark that as your starting angle. Go ahead and mark 40 as your starting angle. Now, which side would be your hypotenuse? Which side would be opposite your 40-degree angle? And which side would be adjacent? We just finished step 1. We labeled the sides based on location compared to the 40-degree angle. So that's what step 1 is, just labeling H, O, and A. Now step 2 really depends on whether we're solving x or y first. Let's say we decided to solve for x first. We would circle x and the one side we know, which is the adjacent side, 6 units long. So circle the side we're solving for, and then circle the one side we know. Now notice how, based off of our labels in red, x and 6 are an opposite side and an adjacent side, an O and an A side. So think in terms of SOHCAHTOA. SOHCAH or TOA, which one has O and A in it? TOA. TOA stands for tangent equals opposite over adjacent. So if we're using x and 6, we have enough information for the tangent equation. So we say tan of our starting angle 40, and tangent's always opposite over adjacent. In this case, opposite would be x and adjacent would be 6 units long. We just finished step 2. We chose the ratio tangent. That involved a combination of one known side and one variable side. Now we have our equation. We could do step 3. We can use our scientific calculators to figure out what tan 40 actually is. You know how you have the sin, cos, tan buttons? Click tan, and then type 40 and press enter. If you do that, you should get about 0.839. It's a run-on decimal. We're just going to round 3 places after the decimal and stop there. So check that you're getting 0.839. If you're getting something else, you might need to change the mode of your calculator to degrees. It might be in a different mode like radians. So all we did here was we figured out tan 40 in our calculator and replaced that side of the equation with what it actually got us in our calculator. So now instead of tan 40 equals x over 6, we have 0.839 equals x over 6. Now we have an equation we could solve. I recommend you get in the habit of putting this side over 1 and then cross multiplying to solve. 1 times x is just x, and then 0.839 times 6 is about 5.03. What I recommend doing in terms of rounding with these problems is, for the work, go 3 decimals in, and then for the last step, just round at the hundreds place, 2 decimals in. So x is about 5.03, roughly. So you successfully solved for x. We're going to run through the same process again to solve for y. So this time we're circling y and the one side we knew from the start. We already did step 1, labeling the sides H, O, and A, but we need to do step 2 for y, choosing the ratio that involves the y side and the 6 side. In other words, something that has both A and H in it. And SOHCAHTOA, which one has A and H? Ka has A and H. So that CAH in Ka tells us that cosine equals A over H. And A over H here would be 6 over Y. You type cosine 40 in your calculator and just round 3 decimal places in. Now here's an example of why I recommend you always put that side over 1 and cross multiply to solve. That's going to help you on problems like this, because notice how this time when you cross multiply, cross multiplying to solve is the only method to solve this time, because you need to get y out from under the fraction bar. When you cross multiply, you get 0.766 times y equals 6. And then you finish getting y by itself. You divide both sides by 0.766, and you get that y equals around 7.83. All right, question 3. Go ahead and mark the one angle you know, besides the right angle, as your starting angle. Label your H, O, and A sides. Which side is H? Which side is O? And then you have your adjacent side. Now, here's a quick tip. If you have a side that has no variable or number on it, it's just a blank side, cross it out, because you know that you can't use that side at all. So the adjacent side's completely ruled out. That helps you realize that to solve this one, you need to use the trig ratio that has O and H in it. If you said sine, well done. So sine of your starting angle equals opposite over hypotenuse, which would be W over 17. Finish solving this problem on your own. You typed sine 54 in your calculator. You put that over 1 so you could cross multiply. You should get W is around 13.75. Question 4. Label your starting angle and then label your sides with the H, O, and A. "12 should be your hypotenuse. It's opposite your right angle, and it's also your longest side. Y is the side opposite 20 degrees, and X is your adjacent side. Now let's say you wanted to solve for X first. Circle the X side and the one side you know. Would that be a SO, CA, or TOA problem? If you said cosine, well done. What would the fraction be? A over H, or in other words, X over 12. You typed cosine 20 in your calculator. Put that over 1 and cross multiplied to solve. Now in the same problem, you still need to solve for Y. So circle Y and the one side you knew from the start. If you have O and H, is that a SO, CA, or TOA problem? If you said sine, well done. Go ahead and finish this problem. You should get about 4.1. Question 5. Find your starting angle and label your sides. Take a look at the screen to see if you labeled your H, O, and A properly. Let's say you chose to solve for B first. Solve for B. If you have an O and A, that would be the TOA equation, tangent equals opposite over adjacent. That should get you about 3.73. Now solve for C. That would be a cosine problem. I want to point out it has to be A over H, not H over A, so it would be 8 over C. I know that throws people off, but sometimes the variable is under the fraction bar if it's on the hypotenuse side. So then when you cross multiply, this time when you cross multiply, it'll take an extra step because you got to get C by itself. Divide both sides by 0.906. 8 divided by 0.906 should get you 8.83 for C, roughly.